Okay, let's talk about two very important integrals if you're doing Fourier series. The first one is we go from negative pi to pi of cosine of nx times cosine of mx. And the other one is the sine version. Let's take care of this one first. And since we're talking about Fourier series, the n and m here, they're supposed to be positive integers, but in reality it's okay. Suppose you have cosine of negative 2x times cosine of negative 9x. Because cosine is an even function, the negative doesn't matter, right? But anyways, we'll stick with m and m being positive integers. And let's get started. For this one in particular, we can actually just use a very nice trig identity. Here, let me write it down for you guys. If we have cosine A times cosine B, this right here is nicely equal to 1 over 2 times cosine of A minus B, and then plus cosine of A plus B. And we can use this to simplify it. Have a look. Here, 1/2 is just a constant multiple, so we can put it on the outside of the integral. And then we still have the integral going from negative pi to pi. And then we just have to have cosine of the first angle minus the other. And because both of them have the x, we can factor it out. We can write it down as n minus m times x, like so. For the second part, same thing, but with the plus instead. And in the middle is also a plus. So cosine of n plus m, and then the x on the outside like this. Okay. Yay. Now we can just integrate them individually. But here's a small trouble. This is cosine of an integer multiple of x. Later on, when we integrate it, we will have to divide it by this, right? So n minus m will be going to the denominator. Well, in that case, we have to make sure that we don't divide it by 0. So we have to actually break down two cases. The first case is that we are going to assume n is not equal to m, so we are not dividing by 0. For the other one, don't worry about it because both of them are positive, so there's no way to get 0 in that case. Okay, the 1/2 is still in the front, and then integrate cosine, we first get sine. It's just a number times x, right? So we keep that. And then divide it by this. So we'll just put on 1 over n minus m. And now, because n is not equal to x, n is not equal to m, so this is okay. Do the same thing for the next one. So we add, divided by this, and then sine of n plus m, and then multiply by x. Okay, and then another big parentheses, and then we go from negative pi to pi. Okay, plugging pi into x here and here. Have a look though. This is going to be integer, likewise that. Sine of an integer multiple of pi is just equal to 0. Very nice, huh? So note that sine of an integer multiple k times pi like this, this is just equal to 0 for all integers k. So in fact, even if you put negative pi in here and here, you also get 0. So all in all, this is just equal to 0. Very nice, right? So now, what if n is indeed equal to m? Let's have a look. And that's case 2. Let me write it down right here. So what that means is, I'm just going to be plugging m into this n. So we will have 1/2 integral negative pi to pi, and then cosine of m minus this m, and of course that's equal to 0, but I'll take care of that later. And then for the other one, do the same thing. Oops. Better this way. And then x. Another one, dx. Okay. Alright, now this is just equal to 0. Cosine of 0 is just equal to 1. So we can just look at this as 1/2 integral going from negative pi to pi of 1. And for this, it's just 2mx. So plus cosine of 2mx. And then just integrate this. So 1/2. Integrating 1 in the x world is x. Integrating this, just like what we did earlier. So plus sine of 2mx. And then divided by 2m. Like that. And then right here, again, we have to go from negative pi to pi. Now check this out. This part, again, it's an integer multiple of pi and negative pi. So the second part is 0. M is positive, so we are not dividing by 0. So this part is done. Now if we put pi into here, minus negative pi, the inside will be 2 pi. 2 pi times 1/2. The result is just equal to pi. So this case, it's also pretty nice. Now, let me put on the summary for you guys. For this integral here, either we get 0 or pi. The case that 0 is when we have n is not equal to m. And if n is equal to m, then we get pi. Done. Now, the other version is we have the integral of negative pi to pi of sine of nx times sine of mx. Let me tell you the great news. The result and the conditions are exactly the same. So this right here, again, either you get 0 or pi. The condition for the 0 is if n is not equal to m, and then if they happen to be equal to each other, then you end up with pi. For this one, well, you just have to use this identity. Sine A times sine B is equal to 1/2 times cosine of these two angles, you subtract them. Now, for this one in between, you have to subtract. Earlier, when we were doing the cosine version, it was add, right? Right now we subtract. And then the second part, it's the same thing, A plus B. You can give this a try on your own. That's it.